Today's lesson is called Properties and Numbers. By the end of today's lesson, you will know what the commutative and associative properties are and how we can use them to simplify expressions. So first off, in your notes, I want you to write commutative and what's behind it. So basically with commutative, it's telling you order doesn't matter. You can flip-flop numbers around during an operation while you are solving. So I'll give you some examples to see how the commutative property works. Now, the algebraic definition of the commutative property is, if you have A plus B, you can flip-flop it and have B plus A moved around. So I want this in your notes, and we'll do some examples with some numbers so you can see it a little better. So, for example, technically, 5 plus 7 is the same exact thing as 7 plus 5. Now, how do I know this? Because I'm going to go ahead and solve both of these and show you that they equal the same exact number. So, what is 5 plus 7? 5 plus 7 is 12. What is 7 plus 5? 7 plus 5 is also 12. So the commutative property states I can do 5 plus 7, and it's the same thing if I were to flip-flop it and make it into 7 plus 5. How do I know that? Because I know I get the same exact answer. Does not matter. Big thing though I want in your notes, I want you to go and highlight property of addition. The commutative property refers only to addition into one other property. Now turn to your neighbor. Is this a commutative property of addition? Yes or no? Well, turning to your neighbor, I hope you recognize that 10 plus 3, if I were to flip-flop those numbers, I would have gotten 3 plus 10. Now if you're still not sure about it, let's solve it. What's 10 plus 3? 13. Then let's take a look at the opposite of it, which would be 3 plus 10. What's 3 plus 10? Also 13. So this is part of the commutative property of addition. We can flip-flop numbers around. Now there's also the commutative property of multiplication. This is an algebraic example. So I want this in your notes. And I would like you to highlight multiplication because this applies to multiplication and addition. Now basically what this says is, if I multiply a number, some number A times B, I can flip-flop it and switch around to B times A. Now I'll give you some examples of some numbers to show you how this works. So let's go and take a look example at the 8 times 4. So by the commutative property of multiplication, technically I can do 8 times 4 and have it equal to 4 times 8. It's supposed to be an 8. Now, is this true? Well, let's double check and see. Here's my 4 times 8, here's my 8 times 4. Do they equal the same number? So, what is 8 times 4? That gives me 32. Then I take a look at my commutative property. What is 4 times 8? It's also 32. So the commutative property of multiplication will work. Doesn't matter which way. You can flip-flop your numbers. And why can you? Because you'll get the same exact answer. Now, take a look at our second example. Is this a commutative property of multiplication? Yes or no? Tell your neighbor why. So you and your neighbor should have noticed, I have 3 times 12 equal to, now is 12 times 3. Now, did I flip-flop these numbers? Yes, I did. And to double check, let's do our math. What is 3 times 12? 3 times 12 is 36. And what is 12 times 3? 12 times 3 is also 36. So this is proof of the commutative property of multiplication. Remember, we're dealing with only addition, only multiplication. So once again, addition and multiplication are commutative. Basically, we can flip-flop. Now, this is kind of sometimes difficult to prove true, but there's something we can prove true. Is subtractive commutative? This one is really easy to prove false. This is not going to be commutative, and you'll see why. What I do want in your notes, though, is I want in your notes what is a counterexample. I want this in your notes. Basically, we give an example that proves something false. It's going to prove it false. That's how we do a counterexample. So in your notes, we're going to do this counterexample. So we have our counterexample. Remember, with the commutative property, all we're doing is flip-flopping. So if I start with 8 minus 5, it should be the same exact thing as 5 minus 8. We flip-flopped. We've flipped or switched the places. So let's do some math. Now, what is 8 minus 5? You should do 8 minus 5 in your head, you should get 3. Now we look at this one though. Now, I have a 5 minus 8. Now, which one is the bigger number? The bigger number is 8. If you notice, 8 is a negative value, so my answer better be negative. And so I'm still subtracting, so let's flip them around. What's 8 minus 5? 8 minus 5 is also 3, but because 8 was bigger, I should have a negative 3. So I have a negative 3. Now, does 3 equal a negative 3? No, it does not. So this is false, and this is my counterexample. I gave an example that made a statement false. So in your notes, underneath your counterexample, I want you to put, therefore subtraction is not commutative. I want this in your notes. And remember, commutative means we're going to flip-flop. Now what we're going to do is we're going to give a counterexample showing that division is not a commutative property as well. So I want you to write down this counterexample as we do it. So here's our counterexample. Remember, commutative property, we are flip-flopping. So if I have 4 divided by 2, I'm going to flip-flop them, and I'll end up having 2 divided by 4 instead. Now the question is, do these equal one another? Hint, it probably isn't. So let's go and do the math and see. So, what is 4 divided by 2? That one should easily be, 2 divided by 4. 2 is going to be my answer. Now this one's a little trickier. Technically, that's 2 divided by 4. It's not going to go into it pretty, but I can reduce it. Because these are both have a factor of 2, so dividing each by 2, I simplify it and I get 1/2. Now, does 2 equal to 1/2? No, it does not. So this is false. I've just given a counterexample, example that proves something false. So in your notes, I want you to go ahead and put, underneath your counterexample, therefore division is not commutative. You have to know which ones are commutative and which ones are not. Now, don't write these down, but we're going to talk them through. Now, number 1. Remember, commutative means we can flip-flop it. Flip-flop it and we'll still get the same results. Now, if you wake up in the morning and then going to school. Now, can you flip-flop this? Can you go to school first, then wake up in the morning second? The answer is no. No, you cannot. Since you can't do that, this means this is not commutative. Now let's take a look at example number 2. In example number 2, we have brushing your teeth and combing your hair. Once again, can we flip-flop these? Can I comb my hair first, then brush my teeth second? Does that make a big difference? Not really. Does it matter? I get the still same result. I'm going to have clean teeth, and then I'm going to have nice hair. Since it doesn't matter about my order, I can flip-flop them. That means that this is going to be commutative. Now, third example. Doesn't matter about my order. Can I put my shoes on first, then put on my socks second? Does that make sense? No, it does not. In this case, order matters. Since order matters, what does that mean? That means it's going to be not commutative. Last but not least, example number 4. So let's say you're having breakfast. Can you drink your orange juice, then eat your cereal? Or can you eat your cereal, then drink your orange juice? Does order matter? No, it does not. Since order doesn't matter, that means that this is going to be commutative. Now another property we're going to learn about is something called the associative property. So I want this in your notes. With the associative property, what we're doing is going to be regrouping. I'll be showing you examples of what I mean by regrouping. So, in your notes, I want you to put the associative property of addition. I'm giving you an algebraic expression. Once again, I want you to notice we're doing this dealing only with addition right now. So, that's why I have a adding, 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 adding. Be careful. Since we're adding all of these, watch and see how I'm going to be regrouping them. So let's go and take a look at my example. I've broken up my example. Technically, we can set these equal to set them equal to one another. 4 plus 2 plus 9 is equal to 4 plus parentheses 2 plus 9. Now, by regrouping, what's the only difference? Take a look. If you look over here, all I've done is regroup the parentheses. So in this case, the parentheses are in front, and then the second case, the parentheses are in the back. Now, is this going to make a matter in how I solve it? Well, let's check and see. Will these two actually be equal to one another? So remember, don't forget your PEMDAS. Remember, we have to do parentheses first. So let's go and solve the first one. What's 4 plus 2? 4 plus 2 is 6. Leave my parentheses if I want. Plus 9. Then what's 6 plus 9? That gives me 15. Let's go and look at my other example. Remember, got to do parentheses first. So 2 plus 9 is 7. Plus 4 is going to give me 11. I'm sorry, ladies and gentlemen. For some reason, I subtracted those two. Let me try that again. So we have 2 plus 9, which will give you 11, plus 4, which is going to give you 15. Now, here's the big question. Does 15 equal 15? Yes, it does. And that's how the associative property of addition works. Basically, all we're doing is regrouping using our parentheses. Now, the next one we're going to do is the associative property of multiplication. I wonder if you're trying to see a kind of a pattern going on here. First I had addition, now I had multiplication. So going right down the algebraic definition. Basically, as long as we are multiplying, what we can do is the same things we can do. Same thing we did before. We can regroup. How are we going to regroup? We're going to be regrouping using our parentheses, starting in the front, and I can flip it down to the back. Watch and see how we prove this with some actual numbers. So based off the associative property of multiplication, if I have 3 times 5 times 7 is equal to 3 times 5, oops, that's a bad 5, 5 times 7, these should be true. Why? Because all I've done is regrouped it. I grouped the first part, and then instead I flipped it and grouped the second part. So let's check our math and see, will this actually be true? Once again, don't forget your PEMDAS. With our PEMDAS, we have to do our parentheses first. So 3 times 5 is 15. I'm multiplying that by 7. So let's see, 15 times 7, 5, 3. So I end up getting a 103. It's supposed to be a 10. Now, let's do my other one. I have 5 times 7, which is 35. Multiplying that by 3. Let's see, what's 35 times 3? 35 times 3 gives me 105 as well. So, oops, it's supposed to be a 5. Sorry. So, does 105 equal 105? Yes, it does. So I've just proved the associative property of multiplication. Now, we've just proven that addition and multiplication are associative. What I want your notes, though, is the give examples that prove subtraction and division are not associative. This is what we're proving. If you notice, subtraction and division, a lot trickier than addition and multiplication. Make sure this is in your notes. So for subtraction, we have our counterexample. So we started with parentheses, 10 minus 3, then subtracting 2. Then we regrouped. Remember, associative property means we regroup. So I regrouped the back numbers. Now let's do some math and see. How is it that this is not going to equal one another? So we have 10, and don't forget your PEMDAS. PEMDAS still applies. We're always going to do our parentheses first. So I have 10 minus 3, which is 7, minus 2. 7 minus 2 is 5. Then, once again, doing my parentheses. So I have 3 minus 2, which is 1. Bring down my negative, bring down my 10. What's 10 minus 1? 9. Whoops, let me make it better, 9. Now, does 5 equal 9? No, it does not. So, we have just proven with the counterexample that the subtraction is not an associative property. So in your notes, under your counterexample, I want you to put, therefore subtraction is not associative. You have to know which ones are associative, which ones are not associative. Subtraction is one of those. Now for division, we have our counterexample as well. So I want you to go and put this in your notes. So based off the idea of the associative property, we can just regroup. I have the first one grouped here, Instead, I'm going to change it and regroup it in the second part. So we're going to prove why is this not true by doing the math. Once again, don't forget your PEMDAS. So, let's do the first part. We have 16 divided by 8. What's 16 divided by 8? That's 2. Bring down my division sign, bring down my 2. What's 2 divided by 2? Well, that's going to be 1. Then, once again, doing PEMDAS, parentheses first. What's 8 divided by 2? 8 divided by 2 is 4. Bring down my division sign, bring down my 16. Now, what's 16 divided by 4? That is 4. Now, does 1 equal 4? No, it does not. So I've just given a counterexample stating that division is not associative. So in your notes, what do you need to put? Underneath your counterexample, I want you to put, therefore, division is not associative. So for this next part, don't write it down. We're just going to be walking this through. So, when dealing with the commutative, and we're dealing with the associative, remember, with the commutative property, what did I do? I started with 2 and a 7, and I flip-flopped it to a 7 and a 2. That's all we're doing. We're flip-flopping. Then with associative, be very careful. What are we doing with associative? Got to take a look at where the parentheses are. I'm starting with parentheses in the front, then I regroup them and put them in the back. So, nice bright letters. We flip-flop for commutative. And then for associative, we're regrouping. Now, here's the big thing though. Just because you have parentheses, it does not imply associative. So what I want in your notes is, parentheses does not imply associative. Not always. Just because there are some parentheses doesn't mean you're going to be like, oh, it's associative property. You have to be very careful. The numbers should stay exactly the same, and all we did was move the parentheses. In this case, they flip-flopped it. They started with 2 plus 7 plus 8, and then they changed it to 8 plus 2 plus 7. Yes, they used parentheses, but did we actually regroup? No, we did not. That's why it's not associative. So be very careful. I want this in your notes. Now we're going to go over some basic identities. So the next step I go over, for right now I want the identity property of addition. It's going to be going in your notes. So identity property of addition is, we have any number plus 0, it's going to give you that number. So any number, we add it to 0, we get that number. So for example, 1 plus 0 is going to give you 1. 2 plus 0 is going to give you 1. 1,000 plus 0 is going to give you 1,000. Anything plus 0, it gives you the same exact number. Then we have the property of addition, identity property of multiplication. So, any number, you multiply it by 1, you can get that same number. So 2 times 1 gives you 2. 20 times 1 gives you 20. Negative 100 times 1 gives you negative 100. Any number that you multiply by 1 is going to get the same exact number. Now we're going over the properties of 0. So multiplication property of 0. Of course, I want this in your notes. Any number multiplied by 0, you're going to get 0. This one you should already know. Now you just have a nice fancy mathematical term to back it up, multiplication property of 0. So, if I have negative 200 times 0, what do I get? 0. Negative 1,000,000 times 0, I get 0. Anything times 0, you're going to end up with 0. Plain and simple. Anything multiplied by, it will be 0. Now, the division property of 0. If you divide any number by 0, you can get an undefined answer. And you ask by undefined, what do you mean? So here's an example that I want you to write down. Let's say I give you 2 divided by 0. Now another way of rewriting it is 2 divided by 0 or 0 dividing into 2. Now, what number, 0 times what number is going to give me 2? Well, the answer is, there is none. No number, when you multiply it by 0, will give you some other number besides 0. So, if you try to divide by it, what do we get? We get this crazy unknown. Instead of calling it unknown, we call it an undefined. So you cannot divide anything by 0. Why? Because you're not going to get an answer. So make sure all of these are in your notes, and make sure you write down this example. Why? Because no number times 0 will give you 2. Make sure you have this example. Now, in your notes, go and write a 2-sentence summary. What did we learn about today? We learned about the commutative property, associative property, identities, lots of things that we learned about today.